Good morning. Let's solve the daily Leetcode challenge. So the problem is Leetcode 2485, title Find the pivot integer. The problem reads, given a positive integer n, find the pivot integer x such that the sum of all elements between 1 and x inclusively equal the sum of all elements between x and n inclusively. Return the pivot integer x. If no such integer exists, return -1. And it is guaranteed that there will be at most one pivot index for the given input. So let's explore some example. For n equal 8, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 equal 21. And when we do 6 plus 7 plus 8, it is also equal 21. So we can see that 6 is the pivot integer for the given number n equal 8. If we take the example 1, 1 is equal to 1 and 1 is also equal to 1. So 1 is the pivot here. And for an example that does not have any pivot, we return -1 for example with 1 and with n equal 4. We can do that. We can check that 1 and 1 plus 2 plus 3 plus 4. There is no pivot in this for n equal 4, because if we try, this will give us 1 and 1 plus 2 3 6 and 4 equal 10. So if we try 2 as the pivot, then we will have 1 plus 2 and 2 plus 3 plus 4. And this gives us 3 and 2 plus 3 is 5. 5 plus 4, 9. They are not equal. So if we try 1 plus 2 plus 3, 3 as the pivot, so we have 3 plus 4. This gives us 6 plus 7. 6 and 7. And if we try 1 plus 2 plus 3 plus 4 and 4, so this gives us 10 and 4. So we can easily see that the number are not equal, so the pivot is -1. Okay, so we understood the different example, and an approach comes to the mind in order to solve the problem. So in order to solve the problem, we will consider that we will try for all the number from 1 to n. We will check if each number can be considered as a pivot. So we know exactly what to do. So for each number from 1 to n, we will check if the number 1 is the pivot, if the number 2 is the pivot, if the number 3 is the pivot. If between them we find one number between 1 and n that is the pivot, then we just return that pivot. Otherwise, we will return -1. I think this problem is most likely related to number theory, and it is just an intuition that we can observe. So for each number going from 1 to n, check if each number can be considered as a pivot. And we can validate if the number is the pivot by checking the sum of the number from 1 to the number and the sum of the element from the number to n. So let's take the example of 8. So if we consider 1 as the pivot, so we will have n, we have the first number here, which is 1, and the sum of 1 to 8, it is 36, if I'm not mistaken. We can see that 1 is different from 36. So 1 is not the pivot. Now we consider 2. So if we select 2, we can have 1 plus 2, it is 3, and 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 will give 36 minus 1, which is 35. 3 is different from 35, so 2 cannot be the pivot. Now we try 3. 1 plus 2 plus 3, it is 6. And 3 plus 4 until 8, it is 35 minus 2, it is 33. 6 and 33 are different, so 3 cannot consider the pivot. 3 not pivot. We do the same for 4. Here 1 plus 2 plus 3 plus 4 is 10. And 4 plus 5 plus 6 plus 7 plus 8 will be 33 minus 3, which is 30, if I'm not mistaken. So the two numbers are different. So 4 is not the pivot. Now we go to 1 plus 2 plus 3 plus 4 plus 5. This is 15. And this is 30 minus 4, which is 26. Different. So 5 not pivot. We do the same for 6. This is 21. And this is also 21. Yes, 21. So we can see that 21 is equal to 21. So 6 is the pivot. And as soon as we find the pivot, we just stop our algorithm and return that number. If we were not able to find the pivot 6, we will continue the algorithm until we have exhausted all the numbers. And if we are not able to find the equality, then we can simply return -1. Algorithm is the following. Okay, so for int I going from 1 to n, so we want to build two numbers, right? So we have two numbers, so we initialize number 1 to 0 and number 2. So the sum of all the elements from 1 to n, and we know that that sum is given by the formula n times n plus 1 all divided by 2. So we have n1 equals 0 and n2 equal n times n plus 1 by 2. Now, what we want to do, we just want to apply this algorithm where we consider one number as the pivot, and we have two sums that we want to build or to construct. So the number 1, n1, will be assigned n1 plus I. And n2 will be assigned n2 minus I minus 1. Because for the first case here, we want to consider the first number. So if I is equal to 1, so we don't want to remove anything. So we will remove 1 minus 1, which is 0. So when it is 2, we want to remove 2 minus 1, which is 1. So that's exactly what we are trying to implement here. So we have n1, we assign n1 plus I, n2, we assign n2 minus I minus 1. And if at some point this number n2 or n1 is equal to n2, then we find our pivot, and in the answer we can assign the pivot I, and we break this loop. And once we break this loop, we can return the answer. And don't forget to initialize the answer to -1, because if we exhaust all the number from 1 to n and we couldn't change the value of answer, then that means we couldn't find the pivot, and the pivot is -1. So That was all for this problem. So that's the solution I was able to find. Let me know in the comment if you were able to find another approach to solve this problem. I will be happy to learn from your solution. Thank you. Bye.